Hello everyone. Our topic for today is to look at reflection, but first let's just consider where we've come from, which is the idea that waves and light refract. So the diagram that you've got in front of you shows that the ray of light is traveling from a material of high refractive index, glass, into a material of low refractive index, air, and that light ray is bending away from the normal. In other words, the angle of refraction is greater than the angle of incidence. Now we know that if we increase the angle of incidence, the angle of refraction also increases and eventually becomes 90 degrees. And at that point, we call the angle of incidence the critical angle. So the critical angle is when the angle of refraction is 90 degrees. And if we increase the angle of incidence even further and we go above the critical angle, then total internal reflection occurs instead of refraction. And we identified that this was a property not just of light, but of all waves. And we will dip in and out of this over the next 18 months. But today's topic isn't that. Today's topic is all about reflection. And you've covered reflection briefly at GCSE, and it's really just a very brief look at it again here. And much like refraction, we'll dip in and out of it. We'll look at the effects of reflection in medical physics in year 13, for example. So what I thought I'd do with you here is just go through very quickly the things that you should already know from GCSE, and then just spend a little bit of time going through how we draw the ray diagrams to show where the object, mirror, and image are when we're looking at things that are reflecting. Okay, here we go. What you already know from GCSE. If you have what is known as a plane mirror, and a plane mirror is a perfectly flat, a perfectly smooth mirror, and if you recall, we sometimes put these little hatchings to show where the reflecting surface is on the mirror, you're going to end up with what is known as specular reflection. Okay, specular reflection is the kind of reflection that produces a really clear image in the mirror. And the law of reflection is that the angle of incidence and the angle of reflection are the same. And that is always true. Okay, remembering we're measuring our angles like we did with refraction from the normal. So if the angle of incidence is 32 degrees, the angle of reflection will also be 32 degrees. However, often we find that we don't get specular reflection because the surface that we're reflecting on is not smooth, it's quite bumpy. And in this instance, we're going to get what's known as diffuse reflection. And this kind of reflection does not lead to a really clear image being produced. However, you need to appreciate that the law of reflection is still being obeyed. So in this diagram, we've got 4 incoming rays, and I'm drawing 4 different normal lines. Now remember, the normal is always located 90 degrees to the surface, but because the surface is changing and is bumpy, so is the kind of orientation of each of those normals, but it is still 90 degrees to the surface at each of those points. So that's the first thing for you just to check that you are happy that that is the case. Now the law of reflection is being obeyed with each of these 4 incoming rays. So with the red ray of light, I and R are equal to each other. You can just see that kind of visually. For the purple rays of light, it's true. For the green rays of light, it's true. And I can't quite squeeze the text in for the light blue rays of light. But in each of those instances, the angle of incidence and the angle of reflection are the same. However, you're not going to get a clear image because let's imagine each of those 4 incoming rays came from the same point in an object. Where they end up going is going to be different. Okay, so you've got a ray of light heading in this direction, you've got a ray of light heading in this direction, but you've also got a ray of light heading right over here. Okay, so diffuse reflection is the kind of reflection you get from a really scratched surface. So if you had a really scratched mirror or a scratched glass surface, you wouldn't get a really clear image of something when you looked at its surface. We have some vocabulary to describe the image that's produced in a mirror. And let's look at these three labels in reverse order. First of all, the image is upright. Obviously, when you look at yourself in the mirror, you are not upside down, okay? You are the same way up as you are in real life. You are laterally inverted, or an image is laterally inverted. Now, what does that mean? It just basically means it's back to front. Okay, so at primary school, you probably did the whole kind of like mystery writing thing in a mirror where you had to write a secret message back to front, stick a mirror in front of it, and the message appears the right way round. As you guys learn to drive, you will notice that you've got that rear view mirror, haven't you, in the middle of your windscreen. And if you've got an ambulance racing up behind you, there's the lettering, the word ambulance is written on the front of that ambulance. Now, if you look at the ambulance in real life, that lettering is actually back to front. And the point of that is when you look at that lettering in your rear view mirror, it becomes laterally inverted. In other words, it becomes the right way round, i.e. you can read it. So images are upright, they're laterally inverted, but they're also virtual. Now, what does that mean? If I illustrate it with this diagram here, you've got an object, just a candle in this instance, and it's some distance x away from that mirror. The image of it appears the same distance behind the mirror. Okay, now these light rays that I've just highlighted here, they don't really travel behind the mirror. It's just where they appear to come from. And that's what we mean by a virtual image. Okay, the light rays haven't actually traveled along that path. It's just where your eye interprets them from coming. So this is what I want to have a look at for a few moments with you now. Much like refraction, okay, we've just got to learn how to do these diagrams. So you've got in your pack a copy of this worksheet here with all of these diagrams on. And you've also got a mark scheme. Okay, now rather than just like blindly copying off that mark scheme, I thought if I just kind of describe and explain to you how they work, and then you can have a go for yourselves, check them up against the mark scheme. Okay, now this isn't going to be the most quick process, me drawing on my tablet here, so you might want to kind of speed this up in places. Otherwise, it's going to be quite a long-winded kind of video. And I'm going to just do 4 of them with you and show you kind of what you need to be thinking about, and then you can do the other 4 for yourself. Okay, right, there is an order that you ought to follow. First of all, let's just label the object, the mirror, and the image. Okay, the first thing that you need to do is to locate where the image is. So the object is the arrow, and it is 3 squares to the left of the mirror. So the image is going to be 3 squares behind the mirror. It's upright. So in other words, the arrow head points upwards on both the object and the image. Okay, so that's the first thing that we do. We draw where the image is. The second thing we do is we draw the virtual lines, not the real ones. Okay, much like refraction, your brain cannot interpret that light has hit the mirror, changed direction, and reflected. Your brain believes that light has traveled in a straight line. So you should really do these in pencil. I'm going to just kind of ink them so I can use some different colors with you. So the light ray that travels in front of the mirror actually did follow that path. So I'm going to use a solid line for that. But when I carry it on to the base of that image, it's a virtual line. The rays of light don't really travel behind the mirror. So what have I done? I've drawn a ruler-drawn line all the way from the eye to the base of the image. And that is where your eye believes the light has traveled. Okay, obviously light has traveled into your eye from the image, not out from your eye. Okay, having selected a ray of light from the base of the image, I'm now going to select a ray of light from the top of the image. And again, the ray of light, I want to just change color. There we go. The ray of light which has traveled in front of the mirror is a real ray of light. That is the actual path that light followed. However, behind the mirror, it is virtual. I'll put an arrow on that as well. Okay. So that's the second thing that you do. The third thing that you do is really just kind of like connecting your rays of light together. So I'm now going to connect the ray of light which came from the top of the image to the top of the object. And similarly, I'm going to connect the ray of light that came from the bottom of the image to the bottom of the object. Okay, both of those are real lines. Okay. In other words, light left the base of the object, hit the mirrored surface, reflected into the eye, and similarly from the top of the object, hit the mirrored surface and went into the eye. Behind the mirror, we've got those virtual lines. Now, I wouldn't add this next bit in green to your diagram because it will just make your diagrams really messy and complicated. Okay, but if I just show you that the law of reflection is being obeyed. So if I just hold my ruler there and just draw a normal, okay, if you have a little look at the angle of instance and the angle of reflection, now it's not perfect and that's just down to how well I can draw the diagram, but the angle of instance and the angle of reflection, okay, should be the same, and that should also be true for the blue line here. Okay, and I've done a really bad job in locating that normal. Okay, but hopefully you can, I'm going to even take that off because that's just terrible. But hopefully you can see that that's true. Okay, so to recap, number one, locate where the image is. Number two, do the rays of light to show where your eye believes the light has come from. So that's going to be a mixture of real and virtual lines, and then connect them back to the object as your third and final step. Okay, I'm going to keep going through these examples with you. And as I said, please do speed up and slow down this video, okay, because it's not a quick process drawing these rays of light on a tablet. Okay, so step number one, let's locate the image. So the base of this arrow is kind of 2 squares in front of the mirror. So the base of the arrow is going to be 2 squares over there. And then it kind of goes 45 degrees. So I think the image is going to look like that. So there's the object, there's the mirror, and there's the image. So first thing that I did then was to pick one end of the image. And there we go. This is where your eye believes light has come from. So it's real and now it's virtual. Okay. And then I do exactly the same for the other end of the image. So from the arrowhead now into your eye, it is first real and then it is virtual. Okay. Let's put some arrow heads on there to show that light is entering your eye. Okay, don't forget those. And then it's a case of just kind of dot to dot. So the red line is originating from the base of the arrow. And these are real lines. And the blue lines originate from the tip of the arrow, and they are also real lines. There we go. And in terms of arrowheads, then light leaves the object and enters the eye after reflecting at the mirror. Okay, so that's not too bad considering that I haven't got a piece of paper. I'm trying to do this on my tablet screen. Okay, so let's have a look at the third one. So the only kind of like slightly complicated bit is the mirror's just annoyingly at some kind of angle, but it doesn't really make it that much more difficult. So first of all, then let's draw where the image is. So I think that nearest corner of that prism is there. So I think the image appears there. We'll just kind of hatch that. There we go. So there's my object, there's my mirror, and there's my image. Okay. So I'm just going to pick two places where the rays of light are going to come from. I could pick more, but I'm just going to pick two. Your rule of thumb is if you pick two, then that's enough to show you where the image is. Okay, if you did 3 or 4, all it would do is just further confirm what you were already thinking. Okay, so let's pick where the light rays come from then. So having identified where the image is, it's where the virtual rays are from first, isn't it? Because it's where your brain believes light has originated from. So in front of the mirror, it's real. Behind the mirror, it's virtual. Okay, and then we do exactly the same with a second point. So in front of the mirror, it's real, and behind it is virtual. Okay, rays of light entering. Okay, and now all we do is kind of join them up. Okay, so let's just kind of make sure I'm about to get this right. So the red ray of light came from that point there, didn't it? Yeah. And the blue ray of light came from there, like that. There we go. Okay, and again, if you imagine drawing your two normals at the mirror, you would see quite clearly that the angle of incidence and the angle of reflection are the same. Okay, so one more, and then I've done more than enough for you to do all of the rest of these independent from me. So this one is just kind of the opposite of what we've had before. So anything dotted is virtual. So the fact that you've got that rectangle and it's dotted means that's not the object, it's the image. And also just have a look at these hatchings here. Okay, so the hatchings show you the back of the mirror, not the front of it. So that means then I've got to draw the object now and not the image. So the object is going to be here, isn't it? Okay. Fabulous. Right. Let's draw our rays of light then. So I'm going to choose the base of this object. And it's real in front of the mirror. That's that side now, isn't it? And it's virtual there. And then I'm going to choose the top of the image. And it's real in front and it's virtual there. Okay, we'll just put some arrows to show that light is entering at the eye. Okay, so now let's just do the images as they leave the object. So the red ray of light came from the base of the object, so that's going to be there. Okay, so it leaves the object and reflects, and then the blue ray of light left the top of the object. And it goes from there. Okay, not perfect, but I'm feeling the pressure of doing this and talking to you and getting it right all at the same time. So I've shown you 4 different diagrams, and I think that's now enough for you to make sense of the other 4. Okay, so I'd like you to complete that worksheet next, and that's all you need to know for now.